So let's recap the basics of LeChateliers. Remember the goal. The goal is to reduce the change. So that change is just stress that's imposed on the system. We don't want the stress, right? Stress is bad. We don't want stress, but stress happens, right? So when stress happens, we want to try and reduce the stress, right? It's always good to reduce the stress. So the goal is to reduce the change, right? And that's our stress, right? So what's our sequence of events? So we try and break it down into 3 steps. The stress is applied, the system responds by shifting, that's speeding up one direction of the reaction, and then 3, what are your new concentrations? How have your concentrations changed? So yesterday we did some activities with up and down arrows and putting that in like a table format. But now when you get the multiple choice questions and the regions type questions, you gotta really try and figure out how to answer them. So try and put things into perspective, and this really helps. The goal, reduce the change. Stress is applied, system responds, what are your new concentrations? And then also we've starred these 4 things to help you go through each question. You want to shift away from what's added towards what's taken away, and then whatever you shift towards increases, and what you shift away from decreases. So remember, think about apparent size. If you're moving towards something, it appears to be getting larger, and if you're moving away from something, it appears to be getting smaller, okay? So if I move my head, right, if I'm back here, now if my head moves forward towards you, it gets bigger. And if it moves away, it gets smaller, right? This is a lot creepier if you're sitting in class and I'm doing this to you in person, or maybe not. Towards gets bigger, away gets smaller, right? Maybe that helps. I don't know. We'll find out. So you want to shift away from what's added and towards what's taken away. Whatever you move towards gets bigger, and what you move away from gets smaller, right? So let's first go to this and look at some of these practice problems on this first sheet. This is the multiple choice examples, right? So there's 2 types of questions that you can get here. One is the easier type. So one type of question is when they give you the stress, and then they ask about the outcome. All right, what happened to the concentrations? Which way did we shift? Those are the easier ones, right? The second type are the harder ones. When the outcome is given, and then they ask for the stress. So these are a little bit tricky. You got to think of these backwards and kind of go and say, all right, here's the outcome. What caused this outcome? And we'll talk about that. So let's look at our examples here. First one, all right, when the temperature is increased, the equilibrium is shifted to the, so pretty much they give you, these are pretty simple. So we're given the stress, temperature is increased, that's the stress, right? Our stress is an increase in temperature. What happens? So think about it. Think about what we went over. You shift away from what's added towards what's taken away. So here's my heat, my temperature. So if temperature is added, I want to shift away from what's added. So remember, the reference point is the arrow. So heat is added, I want to shift away. So away would be to the right. So if I'm moving to the right, whatever I'm going towards gets bigger, and whatever I'm going away from gets smaller. So it helps to just write it right in. Now you've done all the hard work. Now you just got to answer the question, and use the information that you just got out of the question. So we want to shift right. So any left shift is gone. We can rule those out. And how does our concentration change? So the HBr decreased. That's right, right? So the HBr is going to decrease. Done. Those are the easier types. Now the harder types are like this. The concentration of SO3 will be increased. And now you got to go through and see which of these stresses is going to generate the desired outcome. All right? So first thing you got to do is say, okay, you want to increase SO3. So the outcome is we're making more SO3. We want to make more SO3. How do we do that? Shift right. So if we shift right, we're going to speed up the forward direction of the reaction and make more SO3. All right, think about our bologna sandwiches that we talked about in the last lesson. Here's your bread and here's your bologna. If I want to make more bologna sandwiches, I got to use up bread and bologna to do that. So speed it up, make more sandwiches, move faster. Assemble those sandwiches more quickly and you're going to get more sandwiches. So which of these stresses is going to give us the desired result? So now you got to look through these and see which one gives you the desired shift. So decreasing SO2. So these are all stresses. Right? These are all stresses. These are all stresses. Which one is going to give us the desired outcome? Remember, stress is applied, system responds. How have your concentrations changed? So what would decreasing SO2 do? All right, so I want to shift right. If I take SO2 away, so I want a right shift. I want to shift right and make more SO3. So if I take SO2 away, I'm going to go towards what's taken away. I'm going to shift left. All right, so that's no good. Next one, if I take oxygen away, same thing. Here's oxygen. I want to shift towards what's taken away. So now what about pressure? If I increase the pressure, so now we got to count our gas particles. 2 and 1. I have 3 moles of gas on the left and only 2 moles of gas on the right. So if I increase the pressure, I want to shift to the side with less gas particles because I'm going to get less collisions, and that's going to bring my pressure back down. So I want to shift right, which looks to be our answer. Let's go to the last one. See, increasing the temperature away from what's added. My heat's over here, so I shift left. So these are a little bit tricky. You got to do a little bit of work. So my answer is 3. That's the only one that's going to give me the desired shift, which is going to make more SO3. But that's giving you the outcome and asking you about the stress. So these ones are tricky. You got to think about them kind of backwards. All right? So, but use what we went over to help you out. So now let's take a look at this worksheet. That's this one, LeChatelier's principle. So download it, print it out, bring it up on your computer screen, whatever. So the first part, I'm going to let you work on this and do that. But let's take a look at one of these examples. So take a look at number 3. How would a chemist increase the yield of CO2? So this is like the tricky ones. I want to make more CO2. So I want to make more CO2. So it's giving me the outcome and asking me for the stress. So again, how do I make more CO2? How do I make more bologna sandwiches? Put together more bread and bologna, right? You speed up the forward direction of the reaction. Which of these is going to give us the desired outcome? If I take CO away, I'm going to try and put it back, or towards what's taken away. Shift left. Pressure. 2 plus 1 is 3 moles of gas on the left, only 2 moles of gas on the right. So if I decrease the pressure, I'm going to want to bring the pressure back up, so I got to shift to the side with more gas particles, more collisions, bring our pressure back up. If I increase the temperature away from what's added, I'm going to shift left. And if I add more O2, I'm going to shift away from what's added also, but now my O2 is over here, so I'm going to shift right. So that's my answer. So before I give you some time to work on these problems, take a look at question 7 quick. And this one's a little bit tricky because you don't really know what the stress is. So when Na2SO4 is added to the system, what will happen to the concentration of calcium sulfate and the calcium ions? So there is no Na2SO4 in this reaction. But you got to think about what's happening. When Na2SO4 goes into solution, it's going to break up into sodium ions and sulfate ions, right? So what is in this equation is sulfate ions. So this one's a little bit tricky. When you add an ionic compound into a solution, sometimes you got to look at the ions that are produced, and one of those, or both, whatever, might be the ones that are affecting the reaction. So in here, my stress is actually an increase in SO4 ion concentration. So that's your stress in this question. So now you want to use that to answer the question, okay? So take a few minutes and try that question out, and try all these questions out and see how you do. All right, so take a few minutes, work on these problems, go back to the beginning. Okay. So go back to here and work on these problems, okay? One thing quick before you practice these questions. For question 11, letter F, you can't do that yet. We haven't covered that concept yet. We're going to come back to that later on. So just skip F when you're working on these problems. Okay, now that you've taken a few minutes to work on these problems, let's go through them. So number 1, for a system in equilibrium, the rate of the forward reaction and the rate of the reverse reaction must be equal. Remember, rates are equal and concentrations are constant, meaning they're not changing. So number 2, at equilibrium, the amount of products and the amount of reactants must be equal. That is false. They can be equal. They don't have to. It doesn't matter. So what they are is they're constant. They're not changing because the rate of the forward reaction equals the rate of the reverse reaction. All right, we did number 3 together. Number 4, in a reverse reaction, chemical equilibrium is attained when C, the rate of the forward reaction is equal to the rate of the reverse reaction. Not bad. Number 5, which statement describes the reverse reactions? This is a little bit tricky. So now if we're going backwards, if we're going in the reverse direction, if the think about our PE diagram. So in the forward direction, the energy's on the left, right? So that means it's endothermic. Energy is entering the reaction. If we're going forward, right, we're consuming energy, we're absorbing energy. So remember, if you go backwards, it's the opposite. So if the forward reaction is endo, the reverse reaction is exothermic, which is a release of energy. Energy is exiting. So the answer to number 5 here is A. Right, so these are tricky. If you think about the PE diagrams, if you're reading it backwards, now we're starting here and we're ending here. Starting here, ending here. Number 6, which change will not shift the equilibrium? So no effect at all. So the answer here is changing the pressure because 1 and 1 is 2. Only look at your G's. 2 on the right, equal amounts of gases on each side. The system can't respond to any changes, so nothing's going to happen. Neither side is more favorable, so we're not going to get any shift if we change the pressure when there's equal amounts of gases on each side of the reaction. Next up, 7. This one we talked about the stress before. What will happen to the concentration of calcium sulfate? So the stress is increase SO4. So we want to shift away from what's added. So we're going to shift left. Whatever you move towards goes up, and whatever you move away from goes down. So it's always the same. So follow through the steps, and it makes things a lot easier. So what's going to happen? The amount of CaSO4 will increase, and the amount of calcium will decrease. So your answer here is letter A. Next up, number 8. Adding a catalyst changes the rate of reaction by decreasing the activation energy, lowers the hill, or sometimes the Regents likes to say provides an alternate pathway. It's that lowered hill. Right? A catalyst lowers the hill, decreases the activation energy. Number 9. What will the result of an increase in temperature at constant pressure? What will be the result? So what will be the result of an increase in temperature at constant pressure? So this is my stress. What do? Shift away from what's added towards what's taken away. So if we're adding heat, there's my heat, my energy. I want to shift away from what's added. Whatever you go towards gets bigger, and whatever you go away from gets smaller. So the equilibrium is going to shift right, so we can rule out any left shifts. And the concentration of NO2 is going to increase. So if you do the work right in the equation, all you got to do is use your work to help you pick the correct answer, whatever matches up. Number 10. Which change will result in an increase in the product of SO3? So this one's a trickier one. This is the one where they give you the outcome, and you got to figure out the stress. So we want to make more SO3. So how do I do that? Speed up the forward reaction, shift right. Which of these is going to give us the desired outcome? So if I increase the temperature, I'm going to shift away from what's added. So since the energy's on the right, I'm going to shift left. So that's no good. Decreasing SO2, you go towards what's taken away. Same thing with the next one, towards what's taken away. So process of elimination, I'm left with D, but let's see why that's the correct answer. 2 plus 1 is 3 gases on the left, 2 gases on the right. So if I increase the pressure, I'm going to shift to the side with less gas particles, less collisions, and that's going to reduce the change. The goal of LeChatelier is reduce the change and bring our pressure back down. The last part is just going through a bunch of different scenarios here with the same reaction. So I'll go through these quick. If temperature is increased, the equilibrium is going to shift left, right, away from what's added. And if we shift left, the amount of NH3 formed is going to decrease, right, because we're going left. B, if some hydrogen was removed from the system, the equilibrium will shift. So if we take hydrogen away, we're going to go towards what's taken away, shift left. And the amount of NH3 produced is going to decrease. And the amount of N2 will increase because we're going left. Whatever you go towards gets bigger, what you go away from gets smaller. Next up. C, if a catalyst is added to the system, the rate of the forward reaction will increase, but so will the rate of the reverse reaction, and the amount of NH3 at equilibrium will remain the same. Because remember what a catalyst does, it speeds up both directions equally, so it has no effect on our equilibrium. So we're speeding up forward and reverse reactions by the same amount, no effect on equilibrium. D, if nitrogen were added, the equilibrium, so where's nitrogen? Away from what's added, so we're going to shift right, which means our reactants decrease and our products increase. Number 11, if the pressure is increased, so let's count our gases. 3 plus 1 is 4, 2. If pressure is increased, then what do we want to do? We want to bring the pressure back down. So we're going to shift to the side with less gas particles, in this case would be the right, to try and bring our pressure back down. So if we shift right, whatever you go towards goes up, and what you go away from goes down. So the amount of nitrogen is going to decrease, the amount of hydrogen is also going to decrease, and the amount of NH3 is going to increase. Letter F you can skip, we haven't done this yet. Apologize, we're going to come back to that, so don't worry about that if you don't know how to do it. We'll come back to that later on. And that's that. If you have any questions, feel free to email me or post a message on Edmodo, and I'll get back to you as soon as I possibly can.